Hello everyone, we are live for a very special event of Point of Science. We are celebrating Asteroid Day, one day late, it was yesterday. So welcome everybody. I'm here with Alex Karl and Lenka Zikova. So Alex is a main guest tonight. He's a space engineer at a company called Space Application Services in Belgium, where he works on the ISS operations. And Alex, maybe you can tell us how we got in touch and why we are here?
Yes, thank you, Guillaume. So my name is Alex. As Guillaume said, I'm a space engineer and I work here in Belgium for Space Application Services. My day job, basically, is ISS operations. So I've been doing that for 12 years, supporting payloads and the astronauts on the ISS. But now, usually, most of the time, I'm actually in Cologne at the European Astronaut Center and work there. And but my night job, if you want, is asteroids and planetary defense. And that's what brought us together. To mention, yesterday was Asteroid Day. In a little bit, I'll tell you a little bit about what is Asteroid Day and why is it on the 30th of June. So we connected and said, like, hey, maybe Point of Science Belgium should have their own Asteroid Day events. And that's how we got started. And now we're here.
Indeed. And the Point of Science is my day job. By the way, I'm one of the two directors of this organization. We had a festival recently, and we had the pleasure to have Lenka Zikova with us to present. She gave a great talk on how the universe can kill us in many ways, all awful. And she's a space weather scientist. She works at the Royal Belgian Institute for Space Aeronomy. And if you want to learn more about how the universe will kill us eventually, I invite you to check on our YouTube channel. It's the event is recorded there. You can't miss it. It's the one with the most views. It's not a surprise. It's a very interesting topic. We're all paranoid now. She's also a dancer, but she's not going to talk about dance today. She's going to be the co-host of this event with us, share some insights, give her point of view on asteroids, and we'll have a great discussion, the three of us. I'm excited. I don't know if we have already a lot of people online, but if we don't, I'm happy. It doesn't matter. I'm happy to be here with you too. So let's dive into it. Alex, I will give you the floor to tell us more about why we should care about asteroid, why there is an asteroid day in the first place. I forgot to give you the floor, Lenka, to tell us more about your job. I'm sorry. I'm back now. Lenka, sorry. What did I forget to say? Tell me.
Actually, you said everything, so it was perfectly fine. But anyway, hello, everyone. I'm very happy to be here. And indeed, I am a space weather scientist, but my doctorate is in astrophysics and interstellar bubbles, so a bit different topic. Now I work in a space physics group at Royal Belgian Institute of Space Aeronomy, and we focus on space weather. So it's how events on the sun or in the universe can influence our technology here on Earth. It's pretty interesting and influences us on everyday basis. But today we are going to talk about asteroids. And as you said, I'm here because I gave the talk at Point of Science. So I guess it would be fun to have the discussion together later on.
Exactly. Thank you, Lenka. And sorry, I skipped this part. So I was saying, Alex, I give you the floor. Tell us all about how we can die from asteroids and how we can defend ourselves, if possible. I think we all have seen many movies, but it's good to hear from the real scientist about it. So I will.
Right. Thanks, Guillaume. Of course, we try not to die. And speaking about forgetting and skipping, I forgot to give you my asteroid credentials. So I'm also the chair of the IAF Technical Committee on Near-Earth Objects. That's another name for asteroids. The ones coming near Earth, the ones we're interested in. And I'm also one of the co-chairs of the Planetary Defense Conference, which I'm sure we'll mention later on a bit. So, but let me tell you a little bit about asteroids and planetary defense and about Asteroid Day. There we go. So why the 30th of June? The 30th of June, 1908, was a very eventful day, at least if you were living in Siberia. And as far as we know, nobody was around to actually get injured or die from it. There are a couple of eyewitnesses, and I know Lenka will will give us a little insight into that later. But it was the biggest asteroid impact and recorded history that at least humans have witnessed. And as you can see from the pictures, it leveled the forest all around. If this would have happened over a large city, say London, it would have been flattened as well. So that's definitely would have been a bad day. And to not forget that, the UN declared the 30th of June Asteroid Day as an awareness of what these objects can do, and that we might want to be prepared. Because, and this is one of my favorite little facts about asteroids, they're the only natural disaster we can not only predict, but given enough time, prevent. And this is what we're going to look at with Planetary Defense. Back in 2013, some of you might remember this, the internet was flooded with these dashcam videos from Russia, in Chelyabinsk to be precise. Like at 9 in the morning, there was this glowing light in the sky, and it became clear there was a meteorite entering the atmosphere. It made a big bang in the sky, and a couple of rocks fell down. This one was the biggest one. It made a hole in the lake. People went diving for it. They got this, I believe it was 500 kilos, a deep chunk of metal, mostly iron. They got out of there. And what you might not expect is that actually 1,500 people got injured. And you will ask, how can it be that if there's a rock falling in a lake somewhere in Russia, how come that so many people get injured? So, and the answer is because of the shock wave. While the asteroid, or what was left of it, the by then meteor, exploded about 30 kilometers high in the sky, it made a shock wave. So I show you a little video here down in the right, and listen carefully. There it is. So once you see the explosion in the sky, sound travels slower than light. So you will have, depending on the distance, you know it from the thunderstorms. You see the lightning first, and then comes the thunder. So this is the thunder here, but it's a big explosion. So, and this is what destroyed all the windows here. And then, of course, people rushed to the window to say, "Whoa, what's happening there?" And they got it all in the face and other parts. So that's maybe the one takeaway I want you to go home with. Well, you're probably home. So, but is if you see a meteor explode in the sky, wait until the shockwave until you get out. And I'll show you a few more scenes from that video, just to show how much force was behind that. You see the windows just fall out. Okay, oops, watch here. And one more. Sometimes it's not just the window, but parts of the ceiling. As you can see, it's throwing people around. So this is not something you wanna get yourself into. But this is not an isolated event. Those are fireballs, as they're called. The big red one here is Chelyabinsk. It's counted as a fireball. And as you can see, this is over a time frame of, what is that, 30 years. And while fireballs the size of Chelyabinsk are not super common, they're not that rare either. So the Earth is constantly bombarded by rocks from space. And And some of them are big enough to hit us. The most famous one, at least in the Western world, is here at Meteor Crater in Arizona on the upper right. The one below, and this is about 50,000 years old. The diameter is about 1.5 kilometers. So this is not a small hole in the ground. This is decent. But nothing compared to this one. This is one of the biggest and oldest one. This is in South Africa and has a diameter of 300 kilometers. So asteroids do come our way. Again, the most famous one is perhaps the one that killed the dinosaurs about 65,000 years ago. Million years ago. And just for comparison, the rock from Chelyabinsk had a diameter of 18 meters. This one is 10 kilometers. So there's a wide range of sizes that can make local damage, regional damage, up to global devastation, as was the case with this one. And it's not limited to Earth. I mean, you've all seen the moon, you've seen the craters, and most of them are from asteroids. The two pictures here in the bottom, they're actually from Mars, and they're fairly fresh ones. We have satellites around Mars, so they take pictures, so you can see here the impact and how the material is ejected. And this one was in the polar region, so you can see how it's overlaid over the ice. And those are actually here on the upper right, those are meteorites found on Mars. So the rovers there found them on the surface, and they're mostly iron. And also very famous was 1994, we saw a comet impact on Jupiter, where the comet broke apart, and therefore you have several impact points. But this is happening all over the solar system. So where do asteroids live, if usually? So the main ones, or many, are in the asteroid belt that is here between the orbits of Mars and Jupiter. And most of them stay there, so don't get freaked out. Most of them just go around the sun in that distance. And we also have some here way out in the solar system. We have the Kuiper Belt and the Oort cloud. And there sometimes, so the Oort cloud is so far out that sometimes other stars, when they pass by our solar system, they might just nudge one of those rocks in our direction, and then it takes a million years or a few until it comes our way. And that's usually where those come from. How do they look like? So they're basically rocks. So they're different kinds. Some are made mostly out of metal. Some are more made out of carbon, like rocky and icy materials. And this is in scale, so to each other. So you see the big one here, that's Lutetia, that's about 100 kilometers. So this is a big rock. And those are all ones we visited in recent years with spacecraft and flew by. And again, there's nothing here. The smallest one is like Itokawa, but this is still 200 meters, which is significant compared to the almost 20 meters from Chelyabinsk. So this is, even though it looks very small here, they can already make some damage. Getting closer to them, we had some missions. NASA sent the OSIRIS-REx spacecraft to asteroid Bennu, and JAXA, the Japanese space agency, sent the mission Hayabusa 2 to asteroid Ryugu, and they took samples. The Japanese one already came back last December, and they're currently being studied. But you can see it's a very dark place. It's very rocky, the rocks were actually surprising. Most scientists expected more like dust and maybe a few rocks, but this was very rocky, so they had actually some issues taking samples. And here you can see how dark that is. So here's actually the samples that came back from the Japanese probe back in December. It looks like coal, really. It's super dark, and this is also why they're really hard to spot, because asteroids, like all the planets and the moons in the solar system, they only reflect the sunlight. So if we are looking with telescopes, we only have the reflected light to go with. And this is also how we find them. So we have optical telescopes. This one is the formerly known LSST. It has a new name, and I'm wondering if it's Vera Rubin, or is it Nancy? What was the other one? One is a space telescope, one is a ground telescope, and I keep confusing them a little bit. So anyway, so they're building these big telescopes to look farther and see fainter objects, because we want to know where they are, because once we know where they are, we can tell where they're going. And if they're coming our way, we want to know that, of course, because then we might be able to do something about it. The interesting thing about asteroid hunting, as you want, this is also a field where a lot of amateurs are very active and actually contributing a lot to our knowledge, because it's, for an asteroid, it's not enough to detect, to find it, to discover it. It's also to track it, because we need to know how is it moving around the sun to predict its orbit. And this follow-up observations, as they're called, are done to a large degree by amateur astronomers. I mean, this is a telescope. You can argue if that's still an amateur or not, but at least those people are not paid for that. Therefore, they're not professionals. Once an asteroid comes close enough, we can use radar dishes. Unfortunately, the one here on the lower right, which was the most sensitive instrument we have, this is a diameter of 305 meters. It's the Arecibo Telescope in Costa Rica. That unfortunately got damaged, or basically destroyed. There was a storm, and then, well, this thing fell down, and so now it's not usable anymore. They're trying to figure out how to rebuild it, but this was a really important instrument in terms of asteroid research. And you can only use radar when they fly by Earth, and you can get the radar bounces back. So how many are there? So the this is well, depicts the inner solar system. So the yellow star in the middle is the sun. You have the orbits of the planets. So the third one would be Earth, and then you have here Mars. So this is the asteroid belt. And all the green ones, they stay in the asteroid belt. They just go around the sun the happy way, and everything is fine. And the red ones are the ones that are interesting for us, because they come close to Earth. And therefore, we want to keep an eye on them. And therefore, they're called near-Earth objects, or sometimes potentially hazardous objects, because they cross the orbit of the Earth. And if you're at the same time, at the same place, you know what will happen. So we want to know and keep an eye on them. So how many are there of the different sizes? Some scientists made some predictions, because there are some ways to actually do that. So that, and of course, there are less of the big ones and more of the smaller ones. And we can actually make some predictions how many there should be based on the models we have. The good news is everything that's bigger than a kilometer, which would be a global catastrophe, we have found about 95%. So there are only like a handful of objects out there we haven't found yet. However, everything that goes smaller, and 140 meters can still destroy a city, and there we found, well, there's a lot more work to be done. And the smaller ones, less than 100 kilometers, and again, Tunguska was 40 meters. So even the small ones can make it. Well, you will have a bad day if you're in the wrong place at the wrong time. So we definitely want to find them. So before they find us, let's assume we do find one that's coming our way, and this is not real. So this is just as a disclaimer. If we would find one that is coming close to Earth, initially there would always be some uncertainty, because we don't know exactly where the asteroid will be, because of the observations. There's always a little bit of margin. Of course, the closer it comes, the better we know, but we want to know early. So how that would look like is, it's called a risk corridor. That's stretching over a certain part of Earth, and it can go in any direction. So this is really just an example. And now the geopolitics come into play, which can make this really interesting. Let's say it is then predicted, oh, the asteroid will hit Costa Rica. Costa Rica doesn't have a space program, and they will certainly don't want to get hit by an asteroid. So they would probably ask, hey, NASA, ESA, JAXA, ISRO, CNSA, anybody, can you help us? And let's assume NASA would say yes. Okay, sure, we move that thing, they make some deal, whatever, or because they figure out some way of how to pay for this, and then they decide to move it. Based on orbital dynamics, you can actually only move it either to the left or to the right on this line, and sometimes only in one direction, depending on how all the parameters are. And of course, let's say you move it, you move it, and then something goes wrong. And then instead of Costa Rica, it will hit China. China will say, is that really an accident? So you want to coordinate that as best as you can with the international community. And luckily, that is being done. So this is a picture of the building of the United Nations in Vienna. There they have the Office for Outer Space Affairs. And in there, they have a committee for the peaceful uses of outer space. They discuss many things. And one of them is also near-Earth objects. And back in 2014, they gave a recommendation that an action team working on that, and they recommended that. It was approved by the General Assembly. So now we have two organizations, the International Asteroid Warning Network, also pronounced IWAN, and the Space Mission Planning Advisory Group, and that one is pronounced same page, where IWAN is looking at the discoveries, and if they find something and it's meeting certain criteria, they would notify the world and say, hey, there's something coming. And then depending on other criteria, once it's big enough or would make enough damage, same page would get into action and say, like, what can we space agency do about it? And then propose a joint plan. How would a deflection mission look like? Well, you've seen Armageddon, nuclear bomb. It's one option. The question is if you want to send some oil drilling folks or do it in a different way. But so the basic idea is you want that the asteroid is not hitting the Earth. And because it's all over the dynamics, you just need to move it, either break it so it arrives at the spot where the Earth would be a little bit later, or you push it so it goes there a little bit earlier. That's all you need to do, really. And you can do that with brute force. You can blow up a nuclear device nearby. You can also use what's called a kinetic impactor. So you just smack something in there. And again, the earlier you do it, the more the impact compounds. So you can use very small force. If you do 20 years ahead of time, that's all you need. There's also something called a gravity tractor. So in space, well, everywhere, the masses attract each other. So even a small spacecraft attracts a big asteroid to some degree. If you keep it in the right distance, you can pull it a little bit away. And again, this might 20, 30 years ahead of time, this is all you need to move it out of the way. And there are some other ideas with lasers, focusing solar light, and other things. One thing to notice, they all work on paper. Nothing has been tried out yet. But there's good news because there's a mission on the way. It's actually launching on 24th of November this year. It's called DART, the Double Asteroid Redirection Test of NASA. There is an asteroid that's called Didymos, and it has a little companion moon. And they're going to smack into the moon. And they want to see, so they're going to change the orbit of that moon around the main asteroid. And then they can see how effective is that, because it depends a bit on the properties, what the asteroid is made of, and the angle of attack, and a couple of other things. And again, we haven't tried that out. So this is a really good test of technology to see how well prepared are we to take care of some of them. Then in 2024, ESA is launching the Hera mission to the exact same moon to do some follow-up measurements to see how big is the crater and what really has changed, and they're going to study something. So we're going to learn a lot about that. And then I mentioned we want to find them. So one thing which will be launching in 2026, actually, it's the NEO Surveyor, and it has a NEO cam on board. And this is an infrared camera, so it can detect the heat signature of the asteroids. So because they're so faint in the visible light, this is actually also a good method to detect them. And on the upper right here, you see on this one, you see here the colored. This is what Earth-based telescopes can see, which part of the sky, because we can't see to the direction of the sun. This is why the Chelyabinsk asteroid came unexpected, because it came from the direction of the sun. So we didn't see it. We never saw it coming. And the NEO Surveyor will be parked at the L1 spot. So that's between the sun and the Earth. And as you can see, it's complementary to ground-based telescopes. So we will find a lot of, so with the help of the new telescopes that's being built on ground, and the one that we will put in space, we will find a lot of those missing asteroids. And so we know if there's one coming or not. Because the dinosaurs didn't, and you know what all happened. And with that, I'm done and open for questions.
All right, thank you, Alex. It was very interesting. I have already a question. So you're saying, you're saying 95% of the big ones have been found, but it takes only one, right, to get through and mess up all the plans. So is it a good news, 95, or was it a bad news? It was not clear in the way you presented. You sounded positive, but it sounded very negative to me.
Okay, yeah, well, it always depends how you see it. I meant it positive, but I see your point, because indeed, it's true. One is enough. The good news is that those big ones, they wouldn't come as unannounced as some of the smaller ones. Because even if right now they're on the other side of the sun, and that's why we can't see them right now, because again of orbital dynamics, it will take some time until they get around and to our side. So this will not surprise us.
Okay.
In that sense, I'm not losing sleep about it, and neither should you. But we do want to know where they are. This is true.
Okay, and just to be clear, Asteroid Day is not to prepare people's mind for a catastrophe that is coming in the next years, right? There is nothing to worry about.
No, there's none. So the ones we know, there's a list. We keep track of them. We know of none that is going to hit in the next 100 years. There are some that have a non-zero probability, but then it's usually because they've recently been found and we need more observations to say like, oh, okay, now we reduce the margin of uncertainty, and then we know where it will be. And so far, it always missed Earth. And it's more like to get you aware that this is out there, and it's something we should pursue.
I was wondering if I can ask, so you said that there are these exercises that the committee is trying to prepare for if there is an asteroid detected, what to do next. Are there also exercises that are trying to figure out what to do if it hits Earth, like a smaller one, not the complete catastrophe one?
Yes. So this will be a longer answer. I hope that's okay. But it's a great question. No, I love this. No, again, at the Planetary Defense Conference, which takes place every 2 years, all the Planetary Defense community comes together. So you have people who are into discovery, characterization, mission planning, impact analysis, mitigation, disaster management, public education and outreach, you name it. So you have, and in these exercises, you have a hypothetical threat asteroid, and you want to make sure that all those different expert groups have something to do.
Yeah, so, that they are not just sitting
spoiler
there.
alert, the asteroid always hits. or at least a part of it. And the fun part is knowing how or why and when and so on. But in those exercises, it starts like, there's an asteroid that has been discovered, and let's say in 6 years it's coming to hit us, and we think it's this size, but we don't know. But of course, the people of disaster management, they would like to know, like, what's the worst thing that can happen and we need to prepare for? So then they can go and say, like, okay, if it hits here, we have to either evacuate or see or switch off electricity or whatever it is and where it is. So it gets really interesting depending on the scenario. There are, of course, different actions the different actors will take, or if they more than one country affected, like how they coordinate. So this is played as well, and this brings up always questions like, oh, we haven't thought about this. We should look more in this. So next time we're better prepared.
But is there serious funding for all this work, or is it like marginal?
It used to be marginal. So, for example, NASA had actually a mandate from Congress to find 90% of the asteroids larger than 140 meters back in the 90s. But NASA, or at least the NASA now, they have a Planetary Defense Coordination Office, as it's called, who take care of that. They were for many years funded with just $4 million. Which, well, for you and me, that's a lot of money. But for an office protecting Earth from asteroids, that's not very much. And in recent years, they got
a big movie with this, huh?
Sorry?
You can't even produce an asteroid movie with this.
You can't even fake the asteroid
exactly.
deflection. Yeah? No, so, but in recent years, it got more attention also because of Chelyabinsk. Then people were like, oh, this is maybe more real than we thought. And now there's this funding for the Hera mission and for the near Surveyor. So there's some money now put into missions, of course, and also ESA recently just funded the Hera mission. So there's some movement there, but I would say there's still room for improvement.
Okay, maybe what they need to see, the decision makers, would be the slides that Lenka is going to show in a second about the impact of the asteroids in a country like Belgium. Usually it helps to make things more concrete. So I'll let you share your slides, Lenka.
Before I do that, can I have one more question?
Oh, sorry.
Because I'm just wondering, nowadays there is a big problem, fake news. And as you said, that there is also outreach department trying to get involved and probably exercising how to communicate this to public. I guess fake news connected to asteroids impact are a big thing. Is that true?
That is definitely true. Now, this is something that we see because every flyby. So because often, because we look in the sky and we know of objects like 10 years in advance, and we know like, oh, next week there's this asteroid flying by about, I don't know, five distances of the moon, so it's like 1 million kilometers away, which sounds far and close at the same time. So in space that's nothing, but still it's like 2 or 3 times the distance to the moon. So there's absolutely no danger to Earth. But you just need to look at social media every time. It's really, it's very predictable. You will have like newspapers or some blogs or Instagram accounts or you name it. You have like, oh, asteroid is coming, and then you really have to look you have this big headline that says like, we all gonna die. And then if you read like, oh, it will pass in, well, hopefully they put it, but it's like in the details, like, why are you making so much dust about this, Well, so this is definitely a lot of fake news out there, and we are discussing how to address this, or if we need to address this, because if we pick it up, we'll make it bigger than it might need to be. So there's a lot of discussion ongoing, but it's a good point. It's happening.
At the same time, it's not so critical to convince the majority of the population. It's not like a pandemic where you need people to accept to be vaccinated. It doesn't matter if they believe or not. At the end of the day, as long as space agencies are working on it, it doesn't really matter, does it, for people?
That is true. It becomes more a thing if space agencies don't have something to do, and it will hit, and then you need to evacuate. And if then people say, "No, I don't believe it's coming," you're back in like saving lives. If people would move somewhere else, or they all get nervous and say, "I sell my house, I sell everything," So it's a lot of social impact as well.
Yeah.
I'm wondering for the listeners, if they see such a headline, "We are all going to die tomorrow because of an asteroid," is there somewhere, some link, some website where the people can just go and breathe calmly? Is there something you can recommend? Or maybe if there's none, maybe you can discuss it next time at the conference.
Yeah, there are websites, not necessarily that address each concern, but you have the usual ones like NASA, ESA. They have websites about asteroids and the risk list I mentioned earlier, and also where they predict the next week flybys, and they have a list.
It's sometimes difficult to understand these for non-scientists and people who see a table with numbers. It's not always easy to interpret the numbers. So I'm just wondering if there is some website that is more easily approaching people with various backgrounds.
That's a good question. There might be. I'm not aware of one now, but I know, for example, if you know where to look, you can certainly. And that might be the key problem here, that most people don't know where to look.
But in case of doubt, I'm guessing you should just go to space.com, and if it's not the headline there, there shouldn't be.
That is true. No, if there's a real threat, then you can be sure that everyone, including NASA and everybody else, is saying, "Hey, this is a problem."
Indeed.
Nobody's trying to hide any information. So if we discover something that's coming our way,
But Alex, people are watching too much TV. You know how it is. I mean, we're all paranoid. We know that there will be secret societies hiding it. We know it because we've seen so many movies about it. We don't believe you when you say the UN is in charge.
Well, the funny thing is that I sometimes heard it from my family members that, those astronomers, they're hiding things from us. And I'm like, I'm an astrophysicist. What are you talking about? So it's really somehow, yeah. Conspiracy theories. It's a big topic. Anyway, I think let me show you the slides. So
yes,
it's pretty fun. Hopefully. Okay.
Fun. You mean the slides where you show how many people die?
Yeah. Sorry, yeah, I just I'm just weirdly passionate.
Interesting sense of humor.
Okay. So what I have here, I did present it at the Pint of Science, and I want to show how big difference it is if you take an asteroid the same size. Now, in this case, it will be 1 kilometer in diameter, but you have different speed, different angle of entrance into the atmosphere. You have different material, and I will let these two asteroids hit different parts of Belgium. And so I decided Brussels, where is my work? But the worst one goes to Ghent, where I live. So it's not against our institute or anything like that. So we start with the Brussels one. And here we go. So if we have an asteroid that is 1 kilometer wide and is made out of porous rock, going with pretty slow speed of 11 kilometers per second. Like if somebody who never listened to such talks hear speed 11 kilometers per second, it is a high speed for us, but for asteroids, it's at the lower end. And it's pretty shallow entrance, it's like 10 degrees. And if it's aimed to Brussels, what will happen is that it will not hit the Earth in the full size. It will actually become into smaller pieces, and these smaller pieces will fall in an area that is marked on the map with the ellipse. So what you see on the map, it's not like flat crater. It's the area where small pieces would fall. What we will see here in Ghent, is that there would be some ejecta falling over here. It would come about in 2 minutes, as well as air blast. The thickness of the ejecta would be around 2 centimeters. There would be some earthquake, but at the end, it wouldn't be that bad. It is bad, of course, if there are pebbles falling down on you and there's a pretty hard wind. Some buildings would have some troubles as well. But comparing to the next one, it's not that bad. By the way, check the occurrence. This one would occur in about once in 230,000 years. Okay, but and not aiming particularly Brussels. It's about the parameters of the asteroid. Now, if we take the same size of an asteroid, but it goes 50 kilometers per second right away, 90 degrees, iron rich, and it hits Ghent, then it gets really, really bad. Because what you see on the map, it's not an area where it might fall. It is the actual crater, the final crater. It would be 41 kilometers in diameter and nearly 1 kilometer in depth. It's really, really huge. These numbers I give you now is the final crater, because the first crater is usually much more deeper, but later on the edges they actually collapse, and it also falls in the center of the crater. So it's not that deep, but still 1 kilometer is pretty deep. To discuss what will happen in Brussels doesn't make any sense. It's absolutely bad situation. And to show you how bad it would be, let's see how this event would look like for you if you are in Paris. So the ejecta would come there as well in 4 minutes, let's say 4.5 minutes, but the thickness would be 16 centimeters. The air blast would come as well. It wouldn't be that hard as in the previous scenario. There would be some earthquakes, some buildings would have some troubles, but there is one big difference. With this event, with this speed, and actually with the momentum this asteroid would have, there would be a fireball visible. So after the impact, there would be a, let's say, hot bubble of vapor. They would create this huge fireball. That would be around 28 kilometers in a radius. And the duration of the irradiation for you would be 8 minutes. So practically speaking, newspapers, leaves, grass, trees would ignite, would be on fire. So this is the main and big difference, because this causes a lot of trouble and a lot of fires. So as you see, there is a big difference, and it depends on the parameters of the asteroid. However, look at the occurrence. Here, the occurrence is once in 5.4 million years. It's way different. And the reason is that the asteroids, as Alex already shown, they are not flying in the solar system like bees when you are having your picnic somewhere outside. They have some particular orbits. They have particular angles if entering space, or some are more probable than the others. So of course the occurrence also is very, very different. So I wanted to share this with you. And so I'm wondering now, okay, I'm back. Yeah, good. So I'm wondering, Alex, with talking about the composition and the speed, is it somehow, when you discuss, for example, the possibilities how to deflect the asteroid, or how to shift it a little bit from the orbit, how much do you have to discuss, for example, the composition of an asteroid? Is it something like I know how early we can know the composition, but still there are some problems with that. Do you have anything to share about it with the listeners?
Yes. So composition definitely has an impact. It's and obviously once you discover an asteroid, you don't necessarily know what it's made of. So that adds another uncertainty. The same with the size. You don't immediately know. You know, like, oh, if this is a really bright one, it could be small. But if it's really darker than usual, it could be even bigger. So you have a huge range of size. And usually what the decision makers want to know, like, okay, so what are we looking at? What's the worst case scenario? And we have specialists who can model really like impact scenarios. They put in their data this size, and worst case, and they calculate that, and they create maps of what, like, oh, in this area, okay, you have no chance. In this area, you have destruction or here's several degrees of damage. And because this is information decision makers can do something with. They say, okay, if this is the worst case, then maybe we should do something. Or if they say, okay, this is maybe not as bad. It depends, of course, because everything costs money and resources. And
so there is no established threshold where the decision is easily made to say, okay, we don't even bother. It's either too small or whatever, or we start bothering when it's this type of impact or type of asteroid. Is there an easy way to filter these things? Because you mentioned the example in Russia. Was it the kind of asteroid that we should even bother try to stop, or was it just too small?
Well, the one in Chelyabinsk was certainly too small, I would say. I mean, still, it damaged buildings, it injured people. You want to be prepared, at least put a warning out, like stay indoors or something like that. But as I mentioned, the same page group, they only get into action once the object is bigger than 50 meters. And the impact probability, I believe, was it 1 or 10% within the next 50 years, I believe. So if you're crossing those threshold lines, they start thinking about, like, oh, what could we do here? Again, they don't decide. They just give decision makers options to say, like, this is what we could do if you decided to, but it's your call. And then so all these pieces come together. The impact modelers say this is the damage that could occur. The mission people could say this is what we can do about it, and so on. So, and the composition goes in there once we know. And this is also so important to send those missions out and take samples of different asteroids, because so far basically every asteroid we've visited is different from the other, and everyone has a little surprise for us. The one from where the Japanese went, they made actually a small crater to sample subsurface material. So they sent a little metal ball there, and it made a bigger crater than they expected. So, which we have a lot to learn. So it's very hard to predict, at least with the current level, to say, like, oh, it's plan B,
Yeah.
It sounds like a very stressful job these people have.
I don't think anyone is losing sleep, because the probability is really, really low. However, the impact, if it would occur, is really, really high. So it's...
No, but I mean, when it happens, when something gives you a call at 3 a.m. to say, okay, it's coming now, I'm guessing, it's stressful.
Yeah, well, then we haven't done our job, because if it's coming tomorrow, we haven't found it. What we want to hear is, like, we found something that's coming in 30 years, so we can do something about it.
Okay. Fair enough.
I have a question, though. Is there, can you tell our listeners, is there any, how to say it, like alert, warning or warning system that some smaller size meteoroid is coming close by, even if it's discovered, let's say, 15 hours before impact? Is there some warning system?
That is a good question. So far, I believe there were 4 asteroids that were discovered before they actually hit the Earth. Again, they were all super small, like 2 meters, 4 meters, so they didn't do any damage. But of course, it is useful to check the models the scientists have, where they predict where it will fall, and then so they actually discovered 4 small ones before they hit, and of course they disintegrated in the atmosphere of a couple. I think they found even some meteorites on the ground. They went looking for them. A warning system for the small ones, not that I'm aware of. For the big ones, there's discussion, of course, once it's confirmed, then all this UN groups get into action, they inform the member states, and from there, the public. And then usually most countries have their own, like in the US, of course, the president and the army, and I don't know who would get informed. And at some point, then also the general public. But for the smaller ones, again, because they don't do any damage really, at least the ones we found so far, might be interesting to see what happens if the size changes, for example. But so far it's more of scientific interest, and the colleagues were alerted and say like, hey, there's one coming, can you, I don't know, use your telescope, or let's go find those rocks that fell down last night.
Yeah.
But I'm not aware of an actual alarm system like that.
Like if there is one that is, let's say, 20 meters in diameter, it's pretty big and can cause something like Chelyabinsk, then I can imagine that a warning system would be really handy. But I see it the same in the space weather community. We are having similar things, similar exercises, and we are trying to prepare a warning system if there is a big solar storm coming or related events. So I guess it's being built, and maybe it will be built in the future. Who knows? Yeah.
Maybe it could be.
Yeah, and maybe one thing to add was the 20 meters, because and it fits to your Ghent Brussels example. I showed you earlier a picture of the meteor crater, which had a diameter of 1.5 kilometers. This was also done by a 20 to 50 meter object, but this one was all metal.
Ah, yeah, sure.
Compared, and it came down pretty steep, while the one in Chelyabinsk came in pretty flat and therefore exploded high in the air and was made more out of porous rock, as you said. So there you can also see the differences.
Yeah. Mm-hmm.
Alex, you were talking about scientific interest for this kind of asteroids. I'm not a scientist, but I was curious. So before we had this event, I went on Google Map and I typed Tunguska, and I was expecting to find a lot of interest points and pictures from tourists and so on, and there was almost nothing. I found the old pictures from the 1920s, and I couldn't even see a crater on Google Earth. So what's going on there? I mean, Lenka, do you have slides maybe on Tunguska that could...
Yeah, actually, we can...
or not?
I don't know if my slide will help with your with answering the question if you want to see a crater, because there is none. So I cannot show you one.
Is it because it exploded before it hit the ground, or what could it be?
Yes.
Yeah, so that's what happens.
Yeah,
Okay.
there was an airburst. So the best or the accepted explanation what happened there, because people went and looked like, where's the crater? Where are the rocks? And they couldn't find any. But they saw all this damage and was like, what happened here? So the scientists went to work, and they figured out that a rock about 40 meters in diameter exploded in the air, because it came in and got heated up so much, and wasn't made from metal but mostly rocks, and so it just exploded and evaporated. So you had the shock wave, but no material to really rain down or make a crater. So this is why you don't find a crater there.
Okay,
It's pretty fascinating. Sorry. Go ahead.
No, I was going to say, if you don't easily see the material, and if you don't have an obvious crater, how can scientists know or study the past events? Because if they can't see them, they can't really extrapolate. You see the big ones, but if you don't have any, maybe they come every 20 years. Who knows? If you don't see them, so isn't it some sort of a dark area there?
Well, we know it's in a way, but we know that it's not every 20 years, because we have all the satellites in orbit, and some of them were initially just put up to watch the nuclear treaty between the USSR and the US, that they would detect nuclear explosions. They actually find those airbursts. They can see that also on their satellite, and there are infrasound stations all over the world to also catch the sound waves of those.
Okay, so now we can see.
And this is done since the 60s, and obviously this is not happening every 20 years. Otherwise, we would know about it. And the one, and maybe Lenka can add to that a bit, is in Tunguska we have eyewitnesses. There were people who saw that, and
it's indeed like I would like to, if you don't mind, I would like to read one of the what happened by one of the eyewitnesses. But what I want to mention before I read that is what was striking was that the how is it called in English? Like the exploration missions, when they went there pretty late, by the way, in 1921, there was first that didn't visited the site, just talked to the people around. And in 1927, there was the second, not trip, how is it called in English? Sorry, I'm not native. Expedition, thank you. They went there, and what they found out were the trees that were really lying down, and they were following the trees to hopefully find a crater. And what they found instead were trees that were standing. They didn't have branches; they were ripped off the branches, but they were still standing in the middle. The area was like something like 5 kilometers wide, where the trees were still standing. And this is exactly what you would see if there is explosion happening in the, above the ground. So that was one of the reasons why they thought that such an event happened there. And indeed, we have the eyewitnesses. So let me. I will share the screen. I have the text written there, but even though I'm going to read it, it's better that people can also read it themselves. Okay. That's a lot of clicking here to just share a screen. Okay. Sorry. Here we go. Okay. So this one. At breakfast time, I was sitting by the house at Vanavara Trading Post, that is approximately 65 kilometers south of the explosion, facing north. I suddenly saw that directly to the north, over Onkol's Tunguska Road, the sky split in two and fire appeared high and wide over the forest. The split in the sky grew larger, and the entire northern side was covered with fire. At that moment, I became so hot that I couldn't bear it, as if my t-shirt was on fire from the northern side, where the fire was. Came so strong heat. I wanted to tear off my shirt and throw it down, but then the sky shut closed and a strong thump sounded, and I was thrown a few meters. I lost my senses for a moment, but then my wife ran out and led me to the house. After that, such noise came, as if rocks were falling or cannons were firing. The earth shook, and when I was on the ground, I pressed my head down, fearing rocks would smash it, and so on and so on. I find it really interesting how he's describing the heat that and the cascade of the effect. So I just wanted to read it out because that's pretty interesting. And that was 65 kilometers away from the explosion. Yeah. So
how far do you think people saw this? I mean, could we see it from Western Europe, like some light in the horizon or something?
There were some. They did detect, I think, earthquakes, or they did have some detection of probably the earthquakes. But also there were visible special clouds in the night. They are really luminous in the night. And yeah, there was one of the possibilities how to spot it far away.
Yeah, people definitely knew something was happening. There are reports from London who said we could read the newspaper at midnight. So apparently there was some light effect, probably through the clouds that Lenka mentioned.
But sorry, but again, I'm not a scientist, but how come the light could remain more than the moment of the explosion? Because if you read the newspaper, it means that it lasted for a moment, so some minutes with some light. Is the cloud were on fire for a while, or?
I think in this case, if I'm not sure about the London from where the lights came, but I guess that the sky was glowing, and it's because there was either dust, a lot of dust in the atmosphere reflecting, but also a lot of vapor that helps to form this really, really high clouds in a, I don't know how they are, like, I'm not sure, I don't want to say something wrong. And these clouds, as they are so high, they cannot reflect the sunlight, and they are really, really bright. So I guess a combination of those two effects might have caused the light. So it was definitely not the light from the fireball. No, not that. But here I'm a bit guessing.
Yeah, but I would guess the same. So.
Okay, go.
Yeah, sorry, I got stuck on this because when I was a kid, I was reading some bit fantastic magazines, and this thing was featured almost every month there. One day it was a huge asteroid. One other day it was the alien spacecraft. I mean, it was a fascination for me. That's why I have so many questions on Tunguska. There was also an episode in the X-Files series, I think on Tunguska. I'm not sure, but anyway. People are
but it's
fascinated.
interesting that our generation, I probably have the same experience. I remember when I was 6 years old, and we were constantly talking about Tunguska event with the little kids, 6-year-olds. And now when I ask kids around if they ever heard about it, they're like, never heard about it. But I don't know.
Well, then we know about COVID. At least they have something to talk about when they grow old. Sorry.
Well, I guess that's why we have Asteroid Day and no COVID Day yet. So.
Yeah, give it another 20 years and we have a pandemic day. Someone. Yeah. Okay. Time is really flying, and because it's really interesting. Just to move on to another topic that I started discussing with Lenka when we prepared for this was the regulations, because there are committees in place. Alex, you mentioned all of that, but we were curious in practice. For example, who would be in charge of acting, and as Lenka mentioned before, who is in charge of monitoring what private companies could be doing? For example, now SpaceX is launching a lot of satellites. Of course, they have nothing to do with asteroids, but they could be disrupting other space-related activities. So, what's the situation there? Or Lenka, maybe you want to say a few words on that before we turn to Alex?
Yeah, because when we were discussing it, there are not that many regulations about space traffic. For example, at the low Earth orbit. So, for example, Starlink, it's polluting the orbit, and there are no proper regulation to say where to go, what to do, who can be there or not. And there was this big problem that ESA satellite had with one of the Starlink satellites, that they were on the
collision course.
Collision course, thank you. And SpaceX didn't want to move it. And that was a big problem, because then ESA had to move their huge telescope or satellite out and back because of this Starlink satellite. So there are no regulations, and we were wondering about space defense once let's say in the future, where it will be possible to move asteroids easily from there and there. If maybe some private companies will just have fun there and changing orbits. Is it a possibility? Is it being discussed, or it's just a fairy tale?
Well, there are three parts I want to answer this. So first, what's being done? Like, who's in charge? Who decides? That's a good question. We're still trying to figure that out. There is some ideas, so that maybe the UN Security Council has something to do with that. Again, it depends a bit, like who's involved, what is happening, how's the situation looking like. And there are some ideas, but there's no real process yet in place. You mentioned regulations. Yes, there are not many in space, but there are actually 3 that get space lawyers active in planetary defense, give them a real headache. Because one of the deflection methods we have at the moment, we're back at Armageddon here a little bit, but without the astronauts, is the use of a nuclear explosive device, because it is the most effective energy transfer mechanism we have at the moment. So if we don't discover those asteroids early, and we can't use the kinetic impactor or the gravity tractor or any of the other ones, at a certain point in time, we are left with only one option. That is to send a nuclear device up there and detonate it. It might not always be the best idea, because if the asteroid is not made is made from porous rocks, it might break apart, and then you have more than one problem. But the problem the lawyers are thinking about, because you have the Outer Space Treaty that says you're not allowed to put weapons of mass destruction into orbit. Mm. The lawyers wouldn't be lawyers if they figured out a back door, because it doesn't say transport. So if you don't park them in orbit and you just move them to the asteroid, legally it's fine. The problem now, recently we have the, I forgot what it's called, whether it was the non-proliferation agreement, or there was this agreement that, hey, we should get rid of all nuclear weapons, which on Earth, I fully agree, and it's a great thing to do for peace on Earth and safety, security, all those things. But if we would need one, there wouldn't be one. So, and that regulation is a bit more trickier to get around. Apparently, so at the last Planetary Defense conference, we had panels discussing this. It was so interesting. It's actually on YouTube. You can rewatch that. So apparently, the UN Security Council could like overrule that, or say like we make an exception for this case, kind of thing. But there's a lot of legal work going into this. So this far, what regulation or what's regulation concerning planetary defense. Now coming to the private companies you mentioned, there were actually 2 private companies not too long ago who were into asteroid mining. They're not around anymore, but the idea still is. So because especially if there's a lot of metal in those asteroids, or now with the space agencies going back to the moon and Mars, and furthering our presence in the solar system, those companies could think about, hey, we provide resources. A liter of water in space is worth a lot more than a kilo of gold on Earth, almost, because with water you can do a lot. So if you have a company who's mining water and selling it to the exploration activities of the agencies, that's a business case. Same thing if they just go for the minerals and create some sort of infrastructure and economy there, they can make money from asteroids. Okay, nobody's really saying they're bringing them back. And again, there comes a point when it gets too big to bring them back. But it's a good point. There's no regulation about this right now. There is some regulations in the US and Luxembourg that is kind of, because the Outer Space Treaty, which is like the main law for space, was made in the 60s, and they have obviously national actors in mind and didn't think about that a company could ever do this. So this is not in there. But the US and Luxembourg, they because they're interested that their companies do mining or other activities in that sense, they kind of are allowing that. So this is also another interesting legal problem. I'm not a legal person, but that at least sounds very interesting to me, how they're trying to figure that out. But so far there's no regulation. So we will have to see what they come up with. And again, like my early example, what if a small country is being threatened by an asteroid, and instead of asking NASA, they ask SpaceX? It's certainly a possibility if they can do that.
Yeah, it might be that NASA asks SpaceX anyway.
That could be. But it comes back down to the national cooperation or international cooperation. You want to coordinate this. It's a global problem that can only be solved globally, because they can hit anywhere. So nobody is safe.
Is it the same situation with satellites? Because a few years back, I read somewhere that China tested the explosion or the destruction of satellites. So and Russia was also shutting down Mir at some point. So I guess it was all calculated. But whether it's asteroids or human-made objects that could fall down, is it the same realm of regulation or completely different subjects?
No, they're very different, because for human-made objects, it's very clear. Like who launches it has the responsibility. So there was a case, I think a Russian satellite fell down over Canada in the 60s, I believe, and then had a nuclear generator on board. So there was some damage in terms of radiation happening. So Russia had to pay to clean that up, actually, because they were liable. They signed the agreement, and they said, that's also one of the problems was cleaning up space debris, because you can legally only clean up the mess you made yourself. Because Europe cannot go and grab a Chinese satellite and say, hey, even we're cleaning it up, because legally this is still property of the Chinese and they're responsible for that in this example. So it's a lot of international talks and agreements that go in there.
Yeah, I mean, I'm guessing that the industry is evolving and expanding, or I understand it's becoming a real industry, that all these issues might slowly start getting momentum and attention. It's going to be interesting with all the private companies. Lenka, did you have anything else to share?
I agree. Like it's a big thing. We saw in later years how many CubeSats were sent out there, and they are important, but we see how they are, for example, influencing the work of astronomers, for example, or other satellites that are already at the orbit. There is no right of a first one and at a particular orbit. So if there is some satellite already on one orbit, the fact that it was first there doesn't mean that it doesn't have to move, for example. And what concerns me a little bit is truly the projects that are being prepared. I probably heard about it, that there is this meteor shower on demand, that they would send a CubeSat, and if you have a wedding and you just want your personal meteor shower, they would just release particles from the CubeSat, and voila, you have it on the night sky and stuff like that, and brings so much debris. And as we said, there are no proper regulations about cleaning up and so on. That's a big issue, and I guess a lot of energy is going to that right now. Yeah, but
there's definitely still work to be done. So if you're watching and you haven't decided yet what you want to do in your life, consider that as a career option. That's going to be interesting.
Yeah, indeed.
Disaster business. Very good.
That's the future.
Yes, it's the future. All right. Guys, we are 15 minutes behind. It's fine. We're not renting a room. We're all from home. But still, I think it's getting a bit too long for an online event. So before we close and before I give you the closing words, I'd like to say that I enjoyed this topic very, very much. And if there is any way we can make it happen in person next year during the Point of Science Festival or for Asteroid Day later, in a nice location with human beings, that would be really, really great. And I would very much look forward to something like that. So Alex, I hope we stay in touch for next year. And Linka as well, if you're interested.
Definitely.
Right. Guys, anything else you want to say before we close? Or not?
Happy Asteroid Day.
Happy Asteroid Day, yes.
Yeah, so we have a cake or something. I forgot a cake. I'm sorry.
Speaking of Asteroid Day, maybe one thing. If you go to the website asteroidday.org, they have, I think it was June actually, so it might be too late, but there are lots of resources. If you want to learn more about asteroids, that's a good place to start. They have lots of videos and related to events, and lots of astronauts also who are talking about this. So it might be a good place to look.
Excellent. We might put the link on the website also somewhere or on YouTube in case someone forgets. And Lenka, you were saying something?
No, I was just agreeing.
That's good. We're all agreeing. So thank you guys very much. And as Alex said, happy Asteroid Day 2021. We will celebrate next year as well, because there is nothing coming our way in between, apparently. So, yeah.
Nothing we know of.
And that's good enough for me. All right. Thank you.
Thank you.
Bye, everyone.
Thanks. Bye-bye.
Bye.